All right, let's get started. Hello, everyone. My name is Chhavi. I'm from the Wavefront by VMware team. And in this session, we're going to make you all microservices ninja with unified metrics and distributed tracing. So let's get started. And I have a live demo at the end of this session. So I'm going to go very quickly through the slides, rush through them, and then we're going to go show you a demo of that, what we are talking about. Demos are always good. All right. So why are we talking about distributed tracing and metrics, and what's it all about? First of all, in our customer base, in Wavefront's customer base, and in market in general, we are seeing this transition that's happening. And I'm sure you guys are already seeing it too. But the development teams, engineering teams are breaking down their monoliths and converting them into microservices, multiple microservices. In fact, on the left-hand side, I should get to the side. On the left-hand side, you can see an old e-commerce app, used to be a big monolith, and now it is broken down into multiple microservices, each responsible for doing its own thing, whether it's authorization, whether it's catalog, or whatnot. So that's what we are seeing all over the board, that people are breaking down those big monoliths into microservices. And there are many advantages that you get going in this, following this trend and getting that, breaking down these big monoliths. Advantages like increased development velocity. You don't have to wait for that, when can I check in my code into that huge monolith. You can check in your code into the responsible for your own microservice. So increased development velocity is definitely one big advantage. You get a lot of flexibility if you have multiple loosely coupled services rather than a big monolith. Flexibility like, if you take about our team as well, we have some microservices running in Java, some microservices which are in Python. So you get like a flexibility of choosing a polyglot environment based on whatever is your team's preference. Another advantage, better fault isolation. If something goes wrong, it goes wrong only in a particular microservice and not in the your entire website doesn't go down. So there are many advantages. No wonder people are following this trend of adopting microservices. But there are a lot of challenges as well. Some of the challenges, in fact, there are a lot of monitoring challenges, I should say. And a very common challenge that people talk about is, okay, when something bad happens, when your customer says, I went on your e-commerce website and I bought those Air Jordan shoes, but when I was buying it, the experience was terrible. How do you know which microservice was the problem? In a monolith world, you knew, oh, this is a big monolith, you go and look into the logs for that monolith. In a microservices world, you don't know which microservice was responsible, what was the entire request call flow when that problem happened. And those are the challenges which microservices brings to the table. Lack of end-to-end visibility across service boundaries, across process boundaries. When that Air Jordan shoes request came in, which microservices were involved in that request call flow? Was it the authorization? Was it when you were shopping and the cart microservice was slow? What was that visibility? So that lack of end-to-end visibility is one challenge that you have with microservices. Secondly, it's very hard to find bottlenecks. Which microservice is responsible for the slow final outcome? I mean, you can look at each individual microservice and say, okay, what is your average response time? What is your average response time? And we've seen time over and time again that averages are not a great number to look at. You should always look at medians. So, but still, like, what was the problem in that request call flow? And that is why it's hard to find bottlenecks in microservices. And last but not the least, instrumenting, basically tracing across these different microservices. Again, it's not one big monolith, it's multiple microservices. Instrumenting something that can trace your requests across these microservices is not that easy. It's a difficult process, and it's pretty complicated. So that is why microservices brings great advantages to the table, but it does bring a lot of monitoring challenges, and traditional monitoring tools don't work and don't give you that visibility, the end-to-end visibility. Now, and that is where Wavefront comes into play. were you guys here for the last presentation? It was about, they talked about Wavefront as well. Anyone here was here for the last presentation? Okay, so let me give you a quick overview of what is Wavefront. Wavefront is a cloud-native analytics and monitoring platform. We started as a metrics monitoring platform. So we will basically pull in metrics from your applications, from your containers, from your serverless environment, from different clouds, AWS, Azure, GCP, from your infrastructure. All the metrics from the entire stack are sent into Wavefront, which is a SaaS service, and then you can run analytics on them. So you can figure out what's going on, if there is a slow, if your applications are not meeting their SLAs, if there is a slowdown somewhere, where is the problem? You can run analytics using our query language. So, and the solution is built for scale, and you can guess from like some of our customers. Wavefront customers include Lyft, Box, Okta, Workday. In fact, Lyft is sending like billions of metrics per second. So that's the scale that this solution can handle. But now going forward, as I was talking about the trend of microservices and how people are breaking down the monoliths into multiple microservices, in addition to metrics, you need distributed tracing to get that full end-to-end visibility across different services. And that is what we are introducing now. We are adding distributed tracing support to Wavefront, enhancing the application observability. What does it bring to the table? First and foremost, it makes monitoring microservices much more easier. How? First of all, it's an out-of-the-box experience where you get both metrics and traces in one platform for all your microservices. So very, very easily you get visibility into what's happening, is there a problem with all the metrics, and then get the additional context of what was the request flow when that problem happened with going into traces view. So you get that out of the box. It's very easy to add custom metrics. Developers, DevOps, SREs love to add their own custom metrics. So it's very easy to add custom metrics and send it to Wavefront, and you can view all those custom metrics. And if you guys are aware of distributed tracing in general, open tracing and open sensors are the two standards or vendor-neutral APIs that are being followed. So this solution is fully open tracing and open sensors compliant. So out of the box, you get open tracing and open sensors compliant solution, which gives you both metrics and distributed tracing. So it helps you. Another use case for unified metrics and distributed tracing via Wavefront is that it helps you troubleshoot issues faster. When I was talking about that e-commerce app, when your customer went and ordered those Air Jordan shoes, and he said, I had an error, or the request was slow, like when I put in my order, the response time was slow. What happened? How do you troubleshoot? That's where the unified metrics and distributed tracing comes into play. It helps you quickly troubleshoot. You can query it, and by the way, in the demo, I'll show you how you can query. But you can query and say, show me all the request calls that had an error, or show me all the request calls which were the response time was way more than the average response time. So you can quickly query all those requests and troubleshoot issues faster. And last but not the least, you can also figure out, and especially developers love this fact, that they can optimize their applications. They can figure out which applications are the bottlenecks. So out of the box, we'll see in the demo, out of the box you will see what's the critical path and which service was responsible or was taking the longest time in the critical path. So that is the service that you need to probably optimize to make sure that the average response time is reduced. When I talk about the use cases, the next question that usually comes up is, okay, how do I get the data into Wavefront? And some people call it, what's the data pipeline? Some people refer it different ways. But this is how you get data into Wavefront. It's an agentless, lightweight solution. So all you do is you include Wavefront's SDK in your application. So there's no agent, there's an SDK-based solution. You include that SDK, you get the option to either send the metrics directly to Wavefront, which Yeah, you send the metrics directly to Wavefront, or if you have way too many metrics, it's also recommended if you have a lot of metrics, you want to aggregate them and then send them. So then you can run an on-premises proxy that will basically aggregate the metrics and send it to Wavefront. Once you have that in Wavefront, you see both your metrics and distributed tracing in one platform, so you can get the out-of-the-box visibility, you can find bottlenecks, you can optimize applications quickly. All right, so some of the personas that love this solution, first and foremost, definitely SREs and DevOps are the people who are, if something happens and that call comes in, that it's the average response time is slow. They're the one who have to figure out which service is responsible for that. So SREs and developers are the one who, with microservices, they lost that end-to-end visibility into the request call flow. And that's where the first benefit is definitely the SREs and DevOps are the ones who love this solution. They get that full visibility into the entire request flow across services, across process boundaries. Secondly, are the developers. This is a world of going towards DevOps, and going to developer is responsible for the operations piece of their code as well. They want to know how is my service that I'm responsible for is performing. Like, what's the average response time? What's the error rate? And I want to know all these things. So they can easily include, as I was showing in the last slide, they can easily include the SDK in their code and get metrics. When Wavefront is a SaaS solution, there's no on-prem servers to maintain and whatnot. So developers love that, and of course, VP of Cloud, we have like Workday's VP who has recommended us on our website, so go check it out. VPs of Cloud, DevOps, and Engineering, they also love the fact that you get that full visibility so they can reduce their MTTR. How to get started? As I was saying earlier, it's very simple. You include the SDK. If you're familiar with Java, there's the snippet of a Java code, and all it is doing is it's including our Wavefront Java SDK. But you can, we have Python, we have .NET supported as well for unified metrics and distributed tracing. So include your SDK, write less than 10 lines of code. Basically, it's less than 10 lines of code change that includes things like you mentioned, what is your application name, what is your service name, which shard and which cluster are you running it. So those are some of the parameters that you do, but it's less than 10 lines of code change that you do in your code. And voila, you open our web page and you see all the metrics and traces flowing into Wavefront. All right, so before we go into the demo, let me talk a little bit about the differentiators that Wavefront offers, and then we'll go into the demo and show you a live demo of how these metrics and distributed tracing work together. So the first and foremost differentiator of Wavefront's application observability is that it's a single platform for metrics, histograms, and traces. So no more you have to context switch between, okay, you got an alert, and then you look for metrics in one solution, and then you look for the further tracing solution in a different solution. It's one platform that gives you all the three. We often call it three-dimensional microservices observability, three-dimensional in terms of metrics, histograms, and traces. You get all the visibility in one platform. So that's a big differentiator. Secondly, it's a solution which can handle, which was built for scale. It can handle millions of metrics, traces, and histograms. As I was saying, I think I mentioned a little bit earlier, we have customers like Lyft that send us billions of data points per second. So it was built to be a scalable solution. Third, and then you'll see that snippet in the demo as well, but the third fact is that it has built-in support for multiple frameworks and multiple language. What do I mean by that? If you are familiar with Java code, you would be, a lot of people use well-known frameworks like Drop Wizard, Spring Boot, Jersey. They would use gRPC for RPC calls. These are well-known frameworks. And so we know those frameworks, we know what to look for, which metrics to look for in those frameworks. So you just include our SDK, and we already have built-in support for those frameworks. We know we'll pull in those metrics and we'll show you, okay, you're using Drop Wizard, we know which metrics to look for, and we'll show you automatically, this is the response time, this is all the metrics that we achieve from these frameworks. So Drop Wizard, Jersey, Spring Boot, what am I forgetting? gRPC, all these frameworks are built-in supported built-in. And of course, the language support is there as well, Java, Python, and .NET, so you will get all the JVM metrics and whatnot. Another big differentiator is the fact that it's one SDK, so it's a combined SDK for metrics, histograms, and traces. And it's a different tradition. Like earlier, there used to be agent-based solutions. You put an agent, and that worked very well in monolith environments. Now it's an agentless, lightweight solution. And again, I would tell you, lightweight is really important in this context. A lot of people put instrumentation in their code, and the common complaint with a lot of traditional monitoring solutions is, well, in production, it's taking a lot of, it's heavy. The performance impact is quite significant. And that is why you need a lightweight instrumentation solution. And that's what Wavefront is. We're using open source libraries to get all this information, all these metrics out. So it's a very lightweight, agentless instrumentation. And last but not the least, it is open tracing, open census compliant. In fact, we also support, if you are very familiar with distributed tracing, you will know some of the open source tools that are out there, Jaeger and Zipkin. And we often we get that we like customers who are using those solutions, because very soon they'll realize the solutions are great, but they don't scale. So we have like built-in support for Jaeger and Zipkin. What I mean by that is that if you have already instrumented your code using Jaeger or Zipkin, it's like a switch. It's a flip of a switch, and you can send the traces, keep the same instrumentation, send the traces from those libraries into Wavefront, and use Wavefront to view, analyze, run analytics on those traces. So it's all Jaeger and Zipkin are completely supported. So let's go ahead and give you a quick demo. Let's see how much we have time. Okay. And I know this thing takes just a second to switch. All right. All right, so this is what Wavefront looks like. By the way, we have tons of integrations. We have 160 plus integrations, and we can show you all this in a demo. We have a demo booth as well in Venetian, so come check out our booth. I think it's booth number 329. So go check out this booth. We have 160 integrations, so we can pull in metrics from all them. But let's focus on the unified metrics and distributed tracing piece. So when I go into applications, I have multiple applications. So on the top, I have an application called Beach Shirts. This application comprises of many different microservices. So I have 5 microservices here, which is part of the Beach Shirts application. I have a shopping microservice, packaging, styling, delivering, and printing. And this is Java-based application. Then I have a Python-based application, which is kind of a ride-share application, which has multiple microservices in there as well. That's the first screen that you see. And as I was telling you earlier, that we have built-in support for all the frameworks. So we recognize those frameworks, and we will give you all the metrics for these frameworks. So we have recognized that all of them are Java applications, so we know JVM metrics that we have to pull in everywhere. We know these applications are using Jersey as the framework. gRPC is being used here. So we know all the frameworks, and we would tell you which frameworks are being used in which microservice. Now, again, going back to that example, or an alert comes in or a call comes in saying the response time of your application is not that great. It's suboptimal. What do you do? So I know from my application architecture that the first microservice that most of the requests come to is the shopping microservice. So I'll go look into the shopping microservice. And the first view that I look into, let's go to the summary view first, and then we'll go to the detailed view. So the first view I look into, as I was saying, it's a unified platform for metrics and tracing. So the first view I look into is a metrics view of all of the shopping app. I see response rate, I see error rate, I see duration of all the requests that came through shopping app. Now I do see that the request rate is fluctuating a bit, error rate is also fluctuating, but since I got a call that the response time is not that great, and I do see that there are some durations, which are, by the way, on the duration it shows the P95. As we all know, means and averages can be very skewed terms to look at. So you see in the duration time frame, you see some durations, some call durations were actually way more. Almost a lot of them were like 0.3 seconds, and some of them were like 1.7 seconds, or above 1.7 seconds, 1.72 seconds. So that looks like a problem to me. So that's the first metric view that I looked at, and I was like, this looks like a problem. Let me see what's going on. So I go down and see, okay, actually I can even go to a detailed view and look at, is this an application problem or is this a server problem? Is it like some particular cluster that is having an issue, or is it all over? And when I go look at this, let's look at the 1.72. I hope you can see that. When I look at the 1.72, that's the anomalous duration. When I look at 1.72, I see that it is coming from multiple clusters in multiple locations. So it is not a particular cluster or a particular host problem. It looks more like an application problem. So let's go dig a little bit deeper into the application. I see it's the order shirt that has the longer time. So I go click into the order shirt, and what I see is trace view. So we looked at the metric, which was the response time of 1.72 milliseconds, and now I want to see what was the request call flow, what is the trace that happened with that 1.72. This is a summary of all the traces that happened, all the traces for order shirts example. So I can filter a particular trace. There are so many requests that came in, not everything was bad. So, and I am looking for a request that was around 1.72 milliseconds, that request that we saw that was the higher time frame. So I can filter, say, show me the traces which had at least minimum duration of 1700 milliseconds. So I can basically look only for those traces, because if it was 0.3 milliseconds, that looked like the okay thing. So 1.72 seconds is what I'm looking for. So I get all the traces which had the length of 1.72. Now I can dig down into the trace and get that full visibility into what happened when that request came to order the shirt, which all microservices were called after that shirt. So on the left-hand side, you can see when a request came in for order shirts, the request came to shopping app. That's how we started the shopping microservice. Then it went to the styling microservice. Then it went to the printing microservices. Then it went to packaging. And eventually the request got fulfilled. So this was the entire request call flow when a request came in. Okay, all right. Order shirts, but still I don't know why was order shirts taking 1.7 seconds to get fulfill that request. Where was the time being taken? Where was that additional time being taken? So out of the box, you get that distributed tracing view, and you get by the way, the orange line shows you what is the critical path. So you know where is the critical time being taken. So okay, it started with order shirts, then it went to make shirts, then it went to printing, then it went to gift wrapping, and then it went to this packaging gift wrap, and that's the one that took the most bulk of the time. 1.47 seconds were taken in this microservice. So it's not the shopping microservice. It is actually the styling microservice that took the most, or the packaging inside it that took the longest time. This is how you figure out in a distributed architecture which is the bottleneck, which the microservice is the bottleneck, and under which context is it the bottleneck. I can even click on that microservice and see what were the tags associated with it. what was the trace ID, what was, in fact, you can, as I was talking, a lot of customers eventually want to send custom tags as well. So you can see all the custom tags. These are out-of-the-box tags, but if you have added custom tags, you'll see all the custom tags here as well. So now looking at this, I know that, it wasn't the shopping microservice that the problem had, that has the problem. It's actually the packaging one. So once I look at that, okay, now I've narrowed down the microservice, but what is the problem in packaging now? So you have to start again with packaging. Okay, let's look at this microservice and see what is the problem there. So you have an easy way to just focus on the packaging microservice by just clicking on that. I go back to just looking at the packaging service. And by the way, since you are debugging this issue, you would automatically, all the filters would be automatically populated now, because we are in that context that we started with. We are in the same context with this was the source, this was the cluster that we looked at, and these are all the metrics for the packaging app. So now when I look at the metrics for the packaging app, which was taking around 1.4 seconds, so it does look like, yes, it sometimes took 1.4 seconds. So what was going on? What was happening there? And this is where basically the built-in framework supports comes in. This is a gRPC. This is using gRPC framework. So we know the metrics like the payload for that framework. That's a metric for gRPC. So we have automatically populated like what was the payload like in this microservice. And here I can see that it looks like anomalous function that I'm getting very high payloads. If you see both request and response, it's like I'm getting like 700 bytes in request payload. That's a very huge payload. So maybe my application is not optimized to handle that big payload in an RPC call, and that's what basically a developer needs to fix in that particular microservice. They need to optimize for bigger payloads. They weren't prepared for that. So that's how you figured out in a distributed environment, when a call came in that, hey, you have a slow response time, what was happening, what was the entire call flow structure, which service was having the issue, and what was the issue. So that's the magic of having metrics and histograms in one place. So yeah, any questions? I think that was my demo. So, and I'm being told there's 2 minutes left. So yeah, go ahead.
The overhead is of the lightweight agent, or agentless estimating that in?
Yeah, I mean, I don't know if I can give you an estimate, but definitely if you go on our website, our USP is a very lightweight solution. It's like an open source, lightweight way of doing instrumentation. Yeah. Any other questions? Cool. If you have any more questions, we have this demo. We have a beta going on for distributed tracing. So go ahead and enroll for that beta. We are also at the demo booth, so you can go look at a demo as well. Yeah, go ahead. That is correct.
So is that something that you deploy with your microservice communication? Where do you specify?
Okay, so the question is, where do you specify what's the granularity of the data? Like how often do you send data to Wavefront from your environment, right? So the most granular that you can get is 1 second. All right. The most granular that you can get is 1 second. But if you have a proxy, that's where you can. Proxy is the one that's aggregating the data and sending it. It's at the proxy settings that you can define what's the granularity that you want. You can even do it every 10 seconds. Some customers do it like every 10 seconds they want to get the data. We have customers like Lyft that want it every second. So it's at the proxy setting that you define.
Before shipping the data, where the data is stored? Is it like with the same memory as the microservice? Where is the data storage?
So proxy is the place where data is being aggregated for that particular time. So that is the place, and proxy is running on-prem. So if you have a proxy, it's running in your environment right before the firewall. So if you have firewall settings as well, it takes care of that piece as well. So that is where the data is being cached for that particular time. Yep.
Because we are trying to deploy this in a Docker container, right? So our proxy model will So I'm just trying to understand, like, what if the service goes down, right, and comes back up, right? Where does it retain all the things that happen?
Yeah, so it would be at the proxy that it would basically retain, and you can even give it a try. Like I said, there's a 30-day free trial, which includes the proxy as well. So you can set up the proxy and send on our website. It's like a free 30-day trial that you can give it a try.
Yeah, I mean, it looks promising, basically, because we are running into the same problem, right? It's like if we want to know the granular thing, what happened with the microservice.
Uh-huh.
With the agent that we have, we wouldn't get the credit.
Yep.
This sounds very fun.
That's correct. And even when you go for open source solutions, it's not easy. What we've heard from a lot of customers is it wasn't easy to get them. Even the open source solutions, the uptime wasn't there. So and that's where you need something which is like built for scale and built for like the uptime. Yeah. That's correct. Yes. Yes. Yeah. Yeah. I'm getting kicked out. I can stand on the side and answer any more questions.